Hi everyone, welcome back. Before we start today's lesson, let's have you complete this warm-up. It is a review over a topic we covered in the last class, and so I just want to see how well you remember. So what I want you to do is hit pause, and then graph the problem, and then when you're ready to see the answer, hit play, and we'll show you the answer. All right, let's see how we did. There's our parent function. There's the new table for graphing. There's the curve. We're going to use a dashed or dotted curve because it's not or equal to. And then it's greater than, so we shade above. So that's what your graph should look like. All right. So today we're going to be talking about notes 5A.2. We're going to be talking about solving square root equations. All right, let's get started. Our first example wants us to solve 7 plus the square root of 4x plus 8 equals 9. Now, your main focus initially needs to be on isolating that square root. Okay, you have to isolate the radical first. So this is very similar to isolating the parentheses squared or isolating the absolute value. You want that square root by itself. So to do that, we're going to have to subtract 7 from both sides. That gives me the square root of 4x plus 8 equals 2. Now I have to decide, okay, so how am I going to get rid of that square root? So, well, the opposite of taking the square root is squaring something. So I'm going to square both sides to get rid of the square root. On the left, I'm left with 4x plus 8. On the right, it equals 4. From this point on, it's a simple solving equation like we've been doing since Algebra 1. So to solve for x, I have to subtract 8 from both sides. That gives me 4x equals negative 4. I then divide by 4, and that gives me x is negative 1. Now, before I declare negative 1 the winner, I need to plug it back into the original equation because sometimes when we square stuff, it creates those extraneous solutions, meaning that those are the solutions that we get when we solve the problem, but when we plug them back into the original problem, they don't work. So we always want to check to make sure that our x that we solve for is not an extraneous solution. So 4 times negative 1 is negative 4. Negative 4 plus 8 is 4. Square root of 4 is 2. 2 plus 7 is 9. This time it works. So we can declare that our solution is x equals negative 1. All right, let's look at this one. It's a little bit of a challenge. It looks different from the other one. So example 2, they want us to solve the square root of x plus 17 equals 2 times the square root of 2x plus 6. Now this one's a little bit different from our previous example because in our previous example we only had one radical. Now we have 2 radicals. And so you want to make sure that you only have one radical per side. Okay, so in this case, we're not able to isolate the radical. We just need to make sure that we have only one radical per side. All right, so since we can't isolate just one radical, we're going to jump right in and square both sides. So since we have a radical on both sides, we can't isolate it, so we're going to square both sides. Now, when I square the left, that gives me x plus 17. When I square the right's a little bit different. Okay, the right's a little bit different, and let's look why. Because we have 2 times the square root of 2x plus 6 quantity squared. That means that we are basically going to square both items. So that's going to become 2 squared times the square root of 2x plus 6 squared. 2 squared is 4, and then when we square the radical, we get 2x plus 6. So that's how I arrive at this next line. X plus 17 equals 4 times 2x plus 6. Now again, I just solve it like a regular Algebra 1 equation. So I distribute the 4 to both terms on the right, and I get x plus 17 equals 8x plus 24. I subtract x from both sides, and I get 7x plus 24 equals 17. I then subtract 24 from both sides, and I get negative 7 equals 7x. I divide by 7, and I get that x is negative 1. Now, I'm just telling you, not every answer will be x is negative 1. This is just kind of a fluke that it turned out to be that way. So again, we don't want to say, okay, it's right and not check it. What we want to do is we want to plug it back into the equation and make sure that it makes a true statement. So negative 1 plus 17 is 16. The square root of 16 is 4. And on the right, 2 times negative 1 is negative 2. Negative 2 plus 6 is 4. The square root of 4 is 2. 2 times 2 is 4. So that makes a true statement. So we can declare x equals negative 1 to be the solution. All right, let's look at this guy. Example 3. We want to solve the square root of 11x plus 3 minus 2x equals 0. So again, we want to isolate. In this case, we only have one radical. So we want to isolate that radical by adding 2x to both sides. So I get the square root of 11x plus 3 equals 2x. Now at this point, since I've got the square root by itself, I want to go ahead and square both sides to undo that radical. Well, on the left, when I square the square root of 11x plus 3, I'm left with 11x plus 3. On the right, when I square 2x, that gives me 4x squared. Now you'll notice that this has now become a quadratic. This is not a linear equation we have to solve. This is a quadratic equation we need to solve. So what I'm going to do is I'm going to make one side equal 0. So because it's a quadratic, it has to equal 0 to be solved. So I'm going to subtract 11x from both sides, and then I'm going to subtract 3 from both sides. So that gets me 0 equals 4x squared minus 11x minus 3. So I need to factor this. So when I factor it, I get 4x plus 1 times x minus 3. I set each factor equal to 0, and I get that x is equal to negative 1/4, and x is equal to 3. Now, you want to plug this in to make sure that you don't have any extraneous solutions. So when I plug negative 1/4 in, I get negative 11/4. I change 3 to be 12 over 4. And then negative 2 times negative 1/4 is a positive 1/2. So that gets me the square root of 1/4 plus 1/2 equals 0. Well, the square root of 4 is 1/2. Remember, we didn't put that radical there, so we can't put plus or minus. It's strictly 1/2. So 1/2 plus 1/2 is not 0. So therefore, negative 1/4 doesn't work. But let's try 3. So I plug in the 3. 11 times 3 is 33. 33 plus 3 is 36. The square root of 36 is 6. 6 minus 6 is 0. So that works. So this time I got 2 solutions, but one was extraneous. So the only one that worked was x equals 3. Now let's look at example 4. They want us to solve the square root of 3x plus 7 equals x minus 1. So remember, your first step is to isolate the radical. In this case, the radical is isolated. It is completely by itself on the left side. So now I have to go about how do I undo the square root? Well, to undo the square root, I'm going to square both sides. When I square the left, I'm left with 3x plus 7. When I square the right, that's a parentheses squared. Remember when we see a parentheses squared, that means, hey dude, write me twice. So I'm going to change x minus 1 squared into x minus 1 times x minus 1. I'm now going to multiply the right side. You can FOIL it, you can box it, whatever works best for you. So when I multiplied x minus 1 times x minus 1, I got 3x plus 7 equals x squared minus 2x plus 1. This is a quadratic, so to solve a quadratic, it has to equal 0. So I have to subtract 3x from both sides. I also have to subtract 7. When I do so, I get 0 equals x squared minus 5x minus 6. I now have to factor this. So it factors into 0 equals x minus 6 times x plus 1. I set each factor equal to 0, and I get x equals 6, x equals negative 1. But remember, I can't just accept those as being my solution at face value. I have to plug them in and make sure that I do not have any extraneous solutions. So let's plug in 6. 3 times 6 is 18. 18 plus 7 is 25. Square root of 25 is 5. On the right, 6 minus 1 is 5. So that makes a true statement. So it works. Let's try negative 1. Okay, 3 times a negative 1 is negative 3. Negative 3 plus 7 is 4. On the right, negative 1 minus 1 is negative 2. Now I know you're thinking, but wait, negative 4 would be plus or minus square root of 4 is plus or minus 2. No, because we didn't put the radical there. The radical was already there. We didn't put it. So since we didn't put it, we have to assume they want the principal positive. They want the positive only root. So that would be the square root of 4 equals positive 2, not negative 2. So be careful there. All right, so we found out that 6 works, but negative 1 does not. So therefore, I get x is equal to 6. Let's move on to example 5. They want us to solve the square root of 2x plus 1 minus the square root of x equals 1. So, if you'll remember back to example 2 when we had 2 square roots, we needed to make sure that we have a square root on each side, meaning that we cannot have 2 square roots on one side. We only need to have 1 square root per side. So, in order to tackle this problem, the first thing we're going to have to do is we're going to have to add that square root of x to both sides. That way, that enables us to have a square root on the left and a square root on the right, because you're not allowed to have 2 on one side. So that gives us the square root of 2x plus 1 equals the square root of x plus 1. So now that we've gotten this far, we've got only 1 square root per side, we're able to go ahead and square both sides. So I'm going to square both sides. When I square the left, I am left with 2x plus 1. But remember, on the right, a binomial squared, that means, hey dude, write me twice. So I have to change that to the square root of x plus 1 times the square root of x plus 1. Now what we're going to do is we are going to multiply that right side together. Now you can box it, you can FOIL it, whatever method works best for you, that's how I want you to multiply those. So on the left, I still have 2x plus 1. On the right, I have the square root of x times the square root of x, which is the square root of x squared, because x times x is x squared. So the square root of x squared is x. However, when I do the O and the I, the square root of x times 1 is the square root of x. 1 times the square root of x is the square root of x. And then lastly, 1 times 1 is 1. So now I need to do some cleaning up on that right side. So that gives me 2x plus 1 equals x. Now, Square root of x plus the square root of x is 2 square roots of x plus 1. Now, we get to this point where we're like, oh my gosh, I still have a square root in there. How do I make him go away? Well, we're going to start back over with step 1 now. Our goal is to isolate that square root. We want to isolate that square root of x. So we're going to subtract an x from both sides, and we're going to subtract a 1 from both sides. So that leaves me with x equals 2 square roots of x. Okay, so we're almost there. So now that we've got the square root isolated, you're like, wait, it's got 2. It's going to be easier just to jump right in, and we're going to square both sides. I'm going to go to the next slide because I need more room. So here's where we were. We said we're going to square both sides. Now, if you want to divide by 2 and then square both sides, that's okay. But that's going to end up being more work. So I would just leave that 2 attached and then go square both sides. So on the left, that gets me x squared. Now remember, 2 square roots of x squared is 2 square roots of x times 2 square roots of x. So 2 times 2 is 4. Square root of x times square root of x is the square root of x squared. Now the square root of x squared is x. So when I multiply and square that right side, I'm left with 4x. Now this is a quadratic. So to solve a quadratic, remember, one side has to equal 0. So I'm going to subtract 4x from both sides so that my right side equals 0. So that gets me x squared minus 4x equals 0. I can't factor this like a trinomial, but I do notice that both terms have an x. So I can factor out a GCF of x and get x times x minus 4 equals 0. I then set each factor equal to 0, so x equals 0, and then x minus 4 equals 0. And so then I get x equals 0 and x equals 4. Now remember, you do not want to just assume that these are the correct answers. You want to plug them in and verify that they work in the original equation. So I'm going to plug in 0 first. So 2 times 0 is 0. 0 plus 1 is 1. Square root of 1 is 1. Square root of 0, square root of 0 is 0. So 1 minus 0 is 1. So that works. Fantastic. Let's go back and let's try the 4 now. So 2 times 4 is 8 plus 1 is 9. And then the square root of 4 is 2. So 3 minus 2 is 1. So this time both solutions work. So we can say that x can equal 0 or 4, or 0 and 4. All right? Let's look at example 6. It's kind of like a little bit of an application problem, just a little bit different because it's got an x in it, but it's also got a pi. Oh my goodness, holy Toledo Batman. We're going to be okay though. We're going to be okay making it through with a pi. So they want us to use the given equation, y equals 1/2 times pi times the square root of x over 24. We want to solve for x in terms of pi if f of x equals 10. Leave our answer in terms of pi. Well, f of x equals 10. Remember that means y is equal to 10. F of x and y are the same thing. So I'm going to sub in 10 for y. Okay, well, first thing I see that I need to do is I need to get this radical isolated. So I'm going to undo multiplication by 1/2. So that means I'm going to multiply both sides by 2. So on the left, I end up with 20, and I get 20 equals pi times the square root of x over 24. Now, I need to get rid of the pi. So I divide by pi. So that gets me 20 over pi is equal to the square root of x over 24. Well, now that I've got the radical isolated, I'm going to square both sides. So 20 over pi squared is equal to the square root of x over 24 squared. All right, so when I square 20, I get 400. When I square pi, I get pi squared. And then when I square the right side, I get x over 24. Now, we can just cross multiply, or we can multiply by 24. Doesn't matter. You're going to end up with the same answer. Since x is on top, I just multiplied by 24, and it just made it a little bit easier. So that gives me 9600 over pi squared, or 9600 over pi squared is x. And we're not going to make you check that. All right, last example. Let's look at example 7. A computer company models its profit between the years 1995 and 2010 using the equation P equals 1.4 times the square root of x minus 1980, where P is the profit in millions and x is the year. Using this model, in what year was the company's profit 5.94 million? Well, the first thing, let's just talk for a second. What do you think the 1980 represents? Without any further data, we could say that it represents maybe the year the company started, maybe the year they first started tracking this data. Really, without any further information, it could represent a multitude of things, all right, in terms of years. So let's jump into solving. Now, I want to know, when was the company's profit 5.94 million? Now, I don't need to convert this to like 5,940,00. No, we don't need to convert it because P is already in millions. So when P is 5.94, we want to know what year gave us that. So first thing we're going to do is we set it equal. Now, we have to isolate the radical. So to isolate the radical, we're going to divide both sides by 1.4. When I do that, I get 4.24 is equal to the square root of x minus 1980. So now to undo the square root, we're going to square both sides. And that gives me 17.98 is equal to x minus 1980. I add 1980 to both sides, and I come up with 1997.98. So using this model, in what year was the company's profit 5.94 million? Well, at the beginning of 1997, it wasn't 5.94 million yet. So we would probably round up and say in 1998, that's when the company's profit was 5.94 million. All right, so this concludes lesson 5A.2. Your homework is worksheet 5A.2. And if you have any questions, please visit your teacher, or if you're my student, please come see me in tutoring. And if you have any questions, let us know. Guys, please remember the safety mandates we always talk about at the end. Please wash those hands. Please social distance. Avoid large groups and super spreader events. Please stay safe, because we do worry about you, and make great decisions. And we will see you guys back for lesson 5A.3. Have a great one. Bye-bye.